Hi friends, in this lecture we will say about CSMACD. Stands for Carrier Sensing Multiple Access with Collision Detection. We will go through each of these two terms, CS, MA and CD. CS, MA and CD. Let's see first CS. CS stands for Carrier Sensing. Let's figure out one diagram. This is node N1, this is node N2. The multiple nodes N1 and N2 are connected through one same channel, and this is a carrier C. Now the problem arises when both nodes are trying to transfer data at same time. Means when in a case of proper synchronization, when N1 transmit the data and that time N2 will wait, and when N2 transmit the data at that time N1 will wait. Now it means in a similar synchronization, means the similar synchronization till is there, the carrier used properly. But when lack of synchronization, there will be a problem. Let's see what happen when both transmit the data at same time. Means when N1 and N2 senses the carrier at same time and transmit the data, the collision will occur. We will see more information about collision in CD, means in collision detection. So in carrier sensing, there is a main point is for each node sense carrier before transmission. Before transmission. This is what about carrier sensing. Now let's see about MA, means multiple access. Let's draw another diagram. This is node N1, this is node N2, and this is a carrier. Now let's say node N1 sense carrier at t is equals to 0 time, and at same time N2 will sense the carrier at that same time, means the time is also t is equal to 0. It means both channel N1 and N2 are sensing the carrier at same time. In that case what happen? They assume that the carrier is free and no other channel is used this carrier. So what will happen? The nodes N1 and N2 will start transmission of data at same time. And then again the case of collision arises. Due to the collision arises due to the transmission of the data at same time. So in multiple access, the key point is in multiple access what happen, the multiple channel accessing the carrier at same time. This is what about a multiple access. Now let's see CD. CD means collision detection. Wait. Collision detection. Collision detection. We should have a mechanism to detect the collision and resolve it. So basically it is known as a collision detection. Let's draw again diagram. N1 and N2. What will happen when at the same time both nodes transfer the data? As usual, the collision was occurred. Here there is a collision was occurred. So we need to stop that collision and to get inform the two nodes that is a collision is occurred. So what will happen? It produces the jamming signal. What produces jamming signal? And this jamming signal transferred to particular nodes. So in this collision detection, jamming signal was produced. Okay. Now let's figure out what we have seen until now. Some key points. Let's consider one Ethernet LAN, and multiple nodes are connected to this. This is N0, this is N1, this is N2, and this is NN. This is an Ethernet, and N0 and N1 are the farthest nodes from this. Now let's consider N0 senses the carrier C and starts the transmission of the packet or data. Now let's consider at a particular point, this point, at particular point when the first bit of this packet reached, at that same time the node NN also sense the carrier is free to transmit the data. So also NN will transfer the data. At this point what happened? Collision get occurred. So collision occurred and it produces a jamming signal, and jamming signal are travel through node N0. This is the jamming signal. Now in worst case this happen in worst case. The another important thing is there, we should know about the size of packet or frame size. Frame size. So for this let's consider one case when the size of packet is small. So when the size of packet is small, when n0 senses the carrier, it transfer the data and the packet size is small, so there is a collision occurred, and then a jamming signal are coming back to this node. When the packet size is small, means when the jamming signal are come to that node, at that time the transfer of the transfer of packet or data was finished. So at that time when the transfer is finished, then this node n0 does not get any information about the collision. So to avoid this case, we have one idea, that is, second, when we kept the packet size large packet size, so what will happen when we transfer the large packet size to another node? The collision is occurred, and the jamming signal was coming back to this node. But at that time the transfer of the packet will be going on. So at that time when jamming signal are come back to this node, so this node get information, means it detect that there is a collision occurred in transferring of data, and it is need to retransmit the this frame. So he get about the information about the collision, means in this case what will happen, n0 will keep transferring the data for at least the time for which the jamming signal produces by last end comes back to this node. When it happens, this node get information that there is a collision and send or retransmit the frame, and retransmit the frame. And for a packet size, like L by B is equals to 2 into dV, and that is equals to RTT.